Hello, everybody. My name is 0xBrainjar, the founder and CEO of Composable Finance. And today I'll be speaking about the vision of xCVM, which is our solution for cross-ecosystem orchestration and chain-agnostic applications. So we believe that in order to onboard the next billion users into DeFi, that there needs to be a cohesive fabric maintained that allows for developers to be able to construct applications that span multiple different ecosystems and user experiences, first and foremost, that are slick, unique, and allow them to compose functionalities across multiple different ecosystems. So what this actually looks like in practice, typically, if you wanted to perform a cross-chain function, these things would be costly, expensive, and quite filled with a friction-filled experience. So Composable, we're essentially trying to create a solution that allows for people to be able to specify swap on one chain, land on another chain, liquidity provide on a third chain, all from one central application.
Put it on full screen. Mm-hmm. Wait, it's not showing. Wait a second. Full screen? Okay.
Awesome.
All right. This one?
Yes. So what this means for us and for the Cosmos ecosystem is, of course, Cosmos is built on the app chain thesis. For us to scale to multiple different applications running at full capacity to actually onboard the next billion users, the app chain thesis needs to be validated. And we believe with our technical stack that we're doing this to be able to provide a full-fledged interoperability solution for the modular stack, which is begetting these app chains. IBC inevitably will become a protocol that shares states across multiple different ecosystems and chains. And due to this, we have then built xCVM, which is fundamentally an execution layer that becomes dedicated to composing functionalities across multiple different ecosystems and execution environments for then settlement on one specific chain. What this then looks like from a technical perspective is a full-fledged stack dedicated to building these ecosystem-agnostic applications. We have xCVM, which begets applications called modular applications that allow for, again, having an application that runs composed of multiple different chains underneath the hood. This could include as many chains as the developer sees fit. You then have the routing layer, which allows for this agnostic execution of these specific functionalities, which are then communicated via IBC to then settle in these different ecosystems and execution environments. Now, we are the team that is building IBC cross-ecosystem. So for the first time, we're bringing IBC to Polkadot and to Near, and also as many ecosystems as we possibly can. And for this, we've fundamentally invested a lot of resources into this and time because we believe IBC is fundamentally the most secure protocol out there for trustless bridging. And essentially with trustless bridging, we no longer need trusted bridges at all or composing applications comprised of trusted bridges. So xCVM essentially allows for composing applications on multiple different chains. Typically with a cross-chain SDK, you would be limited to just simply 2 different chains, mostly in the EVM context, and a significant lack of orchestration, and also trusted infrastructure. With actual xCVM infrastructure, you'd be able to now orchestrate these various functionalities across multiple different execution environments, meaning that between the EVM and the non-EVM perspective, if you wanted to build an application that was like a perpetual protocol on Evmos but tapped into Osmosis for swaps, you'd be able to do that without even knowing Cosmoverse or Golang. So what is xCVM from a developer perspective? Well, it's multiple different SDKs across multiple different frameworks. The first one is the Cosmoverse SDK. After that is the Solidity SDK, and we're also creating front-end tooling in the form of xCVM.js and a multitude of other cross-ecosystem tooling frameworks to build front-end applications and these chain-agnostic applications, such as our stepper, our transaction visualizer, and also CNS, the composable name service, to map different accounts across different ecosystems. And what my colleagues will be demonstrating later on in this presentation is an actual transaction visualizer that lets people be able to build these applications knowing what's actually happening cross-chain for the first time. With that, I'll hand it off to Carol, our CTO.
Hello, everyone. I'm Carol, Composable CTO. I'm going to keep my bit really short because I want to reserve enough time for technical failures during the demo, just in case. So, real quick, we use IBC as our fundamental transport layer, but IBC in some cases can be quite limited, as well as not really ecosystem agnostic. There are some assumptions about Cosmos really built into that, as well as it sometimes sends very unoptimized messages across. You do a lot of round tripping, as well as that sometimes there are better solutions to doing very complex cross-chain interactions. XCVM for us handles identities and proxies. So interchain accounts is the obvious solution in the Cosmos ecosystem, but they don't exist in Polkadot, for example. They don't exist in Near, and they don't exist in Ethereum. So how do we scale that with our XCVM? We handle account state, and we handle bridging as well. Because even though IBC and trustless bridging is great, in Polkadot we have XCM as well. So there are alternatives to get the same amount of security. Really, as a cross-chain application, you want to be agnostic across different trustless bridging methods, as long as they have the same security. So to kind of summarize, to us, IBC is the very lowest level layer, TCP, providing really secure communication. But what developers want on top of that is something that's more sophisticated, based in API layer protocol, something that is language agnostic. You don't want to deploy Solidity contracts on other chains if your main application is a CosmoverseHQ smart contract. You might not have that experience in-house. XCVM provides the abstractions to be able to interact with DeFi protocols on other chains without actually needing to deploy contracts on those other chains to handle those messages. So instead of needing to run the server example of contracts on both sides, you can just have one contract interacting over XCM to other chains. How that works for an incoming message, coming over IBC into a new chain, into our gateway contract, which basically annotates it, adding some bridging info, in the case, is it IBC or XCM, and handles sending the funds to the accounts. Our orchestrator contract is the singleton contract for each chain that handles a lot of bookkeeping, a lot of state management, and governance. For each account on another chain, we actually deploy an XCVM interpreter contract. This contract makes it so that your accounts on one chain have their own address. This is basically the equivalent of the interchain accounts, being able to own your identity across a different chain. Once a message arrives in the XCVM interpreter, we execute a series of instructions, because we're not just doing generalized message passing, we're not just sending opaque bytes, we're actually sending small programs to other chains. The advantage of doing this is that you don't need to send back a message to your original smart contract on the home chain. You can actually handle the result of your contract calls on the destination chain. And based on that, you can choose to continue execution. You could go back to your original chain, or you could hop to a third chain. You could even split out and hop to multiple chains. This is a way more cheaper way to do very complex cross-chain interactions, because round tripping is kind of the death of paying for gas, because obviously each IBC packet is actually quite expensive. So what do these kind of programs look like? It's just bytecodes. This is obviously the formal definition. If you look at our specification and you're interested in formal definitions, then this should be a good read. But we're really sending very simple bytecode to other chains. And our interpreter contract acts as a VM on top of a VM, executing these transactions. Here we're spawning to another chain, which bridges. And then inside the other chain, we can execute a smart contract call. We can transfer funds to specific accounts. And we can do further spawns to bridge out even more. This is a really flexible way to actually express what you want to do, which also guarantees that's the most optimal way to do this. If you were to handcode this with IBC, you could probably do so, but you'd be deploying contracts on every single chain. With this, you just need one contract on the chain that hosts your main application, and you can still do all of these very sophisticated interactions. I'm going to skip over this, but if you were to handcode this, you'd still be kind of going through this sequence diagram. With XCVM, it's all handled for you. All right, so now our programmers have been working a long time on this demo, and I really want to give them some time to show their stuff. Hussein, our lead developer, is going to walk you guys through the demo, and then June, our lead front-end developer, is going to kind of explain how we visualize these interactions.
Thank you. All right. As just mentioned by Carol, the idea of XCVM is to be chain agnostic and also protocol agnostic. So in this example, we are going to walk through how to do a cross-chain swap using XCVM. And I really wanted to show you at first that XCVM is like an endpoint to the chain, and that just require a bridge, in this case, which is trustless by default, which means no custody of funds. And unless you guys have a PhD or know really well how things work, it's quite difficult today to do cross-chain operation. You need multiple wallets, sign multiple transactions. You need to see whether it succeeded or failed. It's kind of difficult. So the XCVM architecture instantiated to two ecosystems, in this case, in Dotsama, our parachain, which is Picasso, and on Cosmos, the Juno chain. So you can imagine in another universe where TerraSwap was deployed on Juno, which we did there, and XCVM powered for this demo by CosmoSM on both ends, because we support CosmoSM on our parachain, with the bridge being instantiated for Century. So it's an IBC bridge, fully trustless, no custody of your funds while you do cross-chain operation. In this example, you can see, you can imagine that we will start with a bunch of Pika on Picasso. We have an account there. We have no account on Juno, you can imagine that. And the idea is you would like to swap your local tokens against a token that is available on Juno, but not on Picasso, for instance. This is really agnostic because you can imagine this with any chain, with any token. So what you will do is, as Karel previously mentioned, do a spawn, what we call a spawn instruction, which say that you want to move the next instruction of your contract to another chain along some funds. So the idea of a contract is that an XCVM program is that you have multiple instructions, and at one point you can move the continuation on another chain along some funds you have with the program. It's pretty similar to what you are used to in smart contracts, where you have a contract that holds funds, but he's really static on one chain. In this case, he can move around back and forth. So once the program has been moved, the next instruction is what we call a call. It's really protocol agnostic, which means that the call must be encoded for the local protocol. In this case, TerraSwap is a CosmoSM contract, so of course the call will embed a payload, which is a JSON message that will execute the swap against TerraSwap. After that, the account of the contract will hold the USDC. And at this point, we don't know how many USDC we get, right? Like, because you started on Picasso, you don't know the ratio at the moment the swap happened, and you want to bring back absolutely everything. So in this case, you can say that you spawn back to Picasso, pretty much like what we did in the first step, using 100% of the USDC. So no matter how much I swapped, I come back with the whole funds on Picasso. And I will now let you see the demo with the wizard behind the front end, which make this all live with a fancy UI. June, thank you. I can hold it.
Wow, that was a marvelous introduction of something mind-bogglingly complex. Trust me, I've lost hair working with that. Smashing work team. Hi guys, I'm Jun. My focus will be explaining our thought process, mindset, and why certain boxes are 2 pixels to the left. Yes, I'm the monkey brain amongst gigabrain goblins of the XCVM team. I'm a front end. At Composable, we believe that blockchain tech is not enough with being revolutionary. What is the point of revolutionary tech when delivered with a terrible dev experience that makes you want to smash your keyboard on every error? This is the screen that the average blockchain dev has to work with while trying to grep errors, events, transactions out of the console. Sure, it's not impossible, but it's an asymptotically growing net loss for some of the most dear engineers in the IT industry. We at Composable care that devs are using their time efficiently. We want to make sure they can focus on writing core business logic, spend less time debugging to the best of our ability. Henceforth, we believe that a solid, slick, easy to understand UI is of paramount importance and should not be taken lightly, which is why it's my greatest pleasure to introduce to everyone for the first time officially the XCVM developer interface. Now, at first glance, it's just another bloody interface, isn't it? Well, not really. Then what makes this one so special? Well, the Web3 UI UX in the Cosmos ecosystem has tremendously upped this game since Osmosis and Kepler did a bang-up, outstanding job in focusing on terrific UIs for Web3 applications. However, this interface is in a league of its own. It's currently aggregating from 2 different blockchains from 2 different ecosystems, Cosmos and Polkadot. It shows real-time chain data bouncing around asynchronously on different chains, all stitched together based on the initial program composed on the Picasso network. Now, let that sink in for a bit. It's not a blockchain interface. It's not just a cross-chain interface. It's a cross-ecosystem interface, designed without cutting corners for the utmost perfection, tailored for devs exclusively. Rule is for feedback from devs, and always will be. Now for the details. Transactions, instructions executed, XCVM transactions are all updated in real time, making sure you know when chain activity has halted, when graph data is integrated, when it's halted. Orchestrations, searchable by tag to make sure you can find your program with the least hassle. In the future, you'll be able to search with a time frame so you can find your program even without tags, and just a general sense of when it was composed. Processing times, streamed directly from blockchain events, updated in real time. And the visualization screen. We at Composable want to make sure you have all the relevant data as soon as possible, which is why in a single screen, you can see the summary of the orchestration at the top and the visualization at the bottom. With this layout, the state of your cross-ecosystem program is noticeable immediately. Pending instructions in the visualization are grayscaled, so you notice the progress of your program virtually instantly. Events, in order of when the program spawned, paired with the executed event cross-chain, also updated in real time, adjacently for those who need to view the raw data as soon as possible. A copy button, so you can copy any part of the orchestration in JSON format whenever you want, whichever part you want. And last and not least, a rundown of the fees, processing times, and which chain executed which instruction in a more visual format. We're already discussing alternative ways to populate this real estate, as we felt the space had repetitive elements that could be replaced with more relevant insights and data aggregations. As aforementioned, even before the official launch, we at Composable are continuously focusing on what makes a better UX for the developer as a developer, and we have no intention of stopping anytime soon. It's you guys here, the passionate frontrunners of the blockchain industry, daredevils, fearless of bleeding-edge technology, will be the paradigm shifters, composing cross-ecosystem Web3 applications into reality and lead the next wave of game-changing innovation. It's our mission here at Composable to facilitate your cross-ecosystem development journey to be as streamlined as possible. Thank you. Muchas gracias, and viva la cross-chain, viva la fiesta.
Thank you, guys.